Hey, John here. Welcome to the video version of my Computer Science 241 lectures. Let's look at your next assignment, number 8. You're going to create a new version of your MyStack class and a function called evaluate. Let's start with the new class for your MyStack, right? This one is going to say create a stack of integers using a linked list, rather than the array that we had in our last assignment. And otherwise, the operations that you're going to do on that stack are the same. Let's look at a linked list from the conceptual model. What is a linked list? A linked list is a data structure that's comprised of a plurality of node objects. Graphically, we would represent a node like this, and we link them together, hence the name, node 2, let's call that one node 2, and maybe a node 3 like this. All right. There is also an object that represents the list as a whole and where it starts. So there's the head of the list, which points to the first node. All right. So conceptually, we have a series of nodes that are all connected together. The last node is indicated by a link to null or ground as drawn here. So the head points to the first node of a multiple node list, and the last node is indicated by the fact that its pointer to its next node is null. So how do you do this? You come over to the notes for the class, and you find this heading linked stacks right here, and you can see a class with pseudocode definitions all outlined for you right here. So this is the node that we were talking about in general, right? So you've got a node, it has a value of some type, in this case it's an integer. And here's the place where you store a pointer to the next node in your list. This is a simplistic constructor that simply sets the value and the next pointer in one simple call. There's a typo right here. This word and this word, these identifiers should both be value. You're supposed to be saying this right arrow value equals value here, not data. That's just a typo. Now let's look at this for a moment. This right arrow, well, let's correct it first. Here's the correct version that should be in the website. We'll update this at some point, hopefully. For this assignment, you're going to make the value an integer, and it will be changed here and here from the website. Data type here simply becomes int. All right. So the constructor arguments have the same name. Next and value have the same names as the member data items of this structure here, right? So how do you know which is which? Well, inside the scope of the function, the identifier value refers to the closest scoped variable of that name, which would be this function argument right here. So if I simply said value, I'm referring to the function argument. If I say this right arrow value, clearly that is the value member field of the struct node that's being constructed. So this value is that one. This next is this one. So let's look at some code. Here's the struct for the node from the course website. I've got my integer value and my next pointer here. I've got my constructor. I wrote a little main program. Let's see what's happening here. Node star p. This is the p variable. It's allocated where? It's allocated from the. It's allocated in the activation record for main. So at this point, what we have is a single variable called p, whose value is null. Execution then proceeds to this line of code down here. What does this guy do? New. It allocates a new instance of a struct node, one of these guys, on the heap. And then it calls the constructor, passing it a 123 and the current value of p, which is currently set to null pointer. So this will be constructed, setting its value to 123 and the next pointer to null. That whole object, once it's been created, has its address assigned to the p variable in our function. At this point, we have a data structure that looks like this. Now, what if we want to modify our data structure and put another node in it like this? So let's say I want to put a 4, 5, 6 right here, and then have it point to this guy down here, and make P point up like that, okay? This now is starting to look like a list. This is what we call a linked list, a singly linked list. It has a single pointer that goes between each one of the nodes in the list. So the first one, as drawn right now, the first element is the 4, 5, 6 value. The second element will have a 1, 2, 3 value. So let's modify our program here to create that data structure. So what do we do? Well, we can just keep on kind of playing this game, right? So there's a 4, 5, 6. So now what have we done? We've said allocate another node, make the next pointer of this new node 4, 5, 6 point to whatever P used to point to, which was the 1, 2, 3 node. And when we're done with that, update P to point to the 4, 5, 6 node. So that matches our diagram exactly. As you can see, if you keep repeating this operation, you're essentially pushing things onto the front of your linked list. So this would then push a 7, 8, 9 in front of the 4, 5, 6, and this would just keep on going. So this is the order of the operations that you need to execute if you want to use a linked list to implement a stack when you're pushing items into the front of the linked list. So how then do we remove things from our list? Now again, we're using it as a stack. These three operations here essentially push onto the front, of our stack. I'll put that in quotes because it's a linked list that is implementing a stack data structure, all right? So these push things onto the front of our stack. So how do we then pop things out of our stack? To pop something out of our stack like the 7, 8, 9, we need to move the pointer P back to the 4, 5, 6 node and then delete the 7, 8, 9 node. So how do we really do that? Well, we can say what? We need to remember where the 7, 8, 9 node is, right? Because P currently points at it. If we move P away, we'll forget where it is. So we're going to say node star temp. Maybe we'll have a temporary thing here, right? So I'll say save it in P. Then we can say P equals P right arrow next. And with that, we can say P now points to the, the 4, 5, 6 node. Now all we need to do is get rid of our temp thing. We say delete temp. So what happens then to our data structure here? Well, that we got is this temp variable that we've added, right? We've assigned it the value of P, so that means that it's going to point over to here because that's where P currently points. After that, we're going to say P equals P next. Well, P points to this guy, and there's the next pointer right there. So this is going to change to point to here. All right? So now we have temp pointing to 7, 8, 9, and we have our P pointing to 4, 5, 6. At this point, I can delete the 7, 8, 9. We don't need it anymore. We're popping it off of our stack. And we're back to this. Now, this temporary variable is a dangling pointer to nothing, but that's okay as long as we don't use it to access the deleted node. All right, so how do we take this and make a stack object? Well, you're going to create a new my stack. It's going to have two data members. You don't need any more. It's going to have a stack top, which is the head pointer, and the size, number of items that are in the stack right now, just like your last assignment had. So what do we got? We got a default constructor, set it to empty, and same as last time. Set the number of items in the stack to 0, and you can initialize the stack top pointer to null pointer. You don't need to reserve a size or anything, because what we're going to do is we're going to allocate, we're going to use new to create new objects of type node every time somebody pushes something into the list, and every time they pop it out, we'll return the value and then delete it. using the logic you just saw a minute ago. Size, return the size, empty, no problem. You use the size member field for those. Clear, this is not a problem. It works a little differently than your last assignment. This one you can just keep calling pop until the number of items in the stack becomes 0, and we'll look at pop in a minute. Top, to get the top value, you take the pointer that points into the first node and you grab the value out of that, right? So that would be stack top right arrow value would be the top value in the stack right now. Okay, so now we get to the blood and guts of this thing. What does push do? Well, these 3 lines of code here in their pseudocode is exactly 1 line right here. New stack top equals, create a new node, set the value, and tell it the old stack top for the next pointer in the new node. So what does he say here? Put the value in, put the current stack top into the next pointer, and set the new current stack top to the address of the new node. So all 3 of these lines here, like I said, is just 1 line of this code here. And of course, you have to add 1 to your stack size. Remember how many items are in the list. And that's all you need to do for push. Pop, we already saw the code for this too. What do you need to do? You got to remember where the current stack top is. So you store that in a temporary variable. You then say that the new stack top equals the second item in your list. It grabs the next pointer out of the current top that you're popping and throwing away right now. Then you can delete the temporary object and then subtract 1 from the size. So that's this code down here. Make a temporary pointer. Remember where the current top of the stack is. Set the new stack top equal to the second item in your list. Delete the old top 1. And of course, down here, this is just a test of the linked list itself. In the stack, you have to deal with your counter and your size, remembering the size as you go, okay? And there's your pop. What do you do for your copy and your assignment operator? You do the same sort of thing as you did before. This object only has 2 fields, so you make the copy of the 2 fields. And we're going to call clone this time because we're going to write a little utility function, because copying a linked list is more complex than just copying an array. So we're also going to use it in the assignment operator, right? So we're going to factor that out and make everything simpler. What do you do in your assignment operator? Same as you did before. Make sure you're not assigning it to yourself. You can call clear to make sure that the L value has an empty stack. We talked about that earlier. You just keep calling pop to get rid of them all. Then you copy the size and clone the contents. All right. That leaves us with clone. All right. Well, the destructor is hiding up here as well. Just call clear to get rid of all the stuff, because you want to free up any nodes that might be in the stack before you delete the stack itself, because otherwise those objects will be lying around the heap and become orphaned objects. Now we have 2 cases that we have to concern ourselves with, right? So well, what if we're cloning a my stack that has no nodes, or a my stack that has 1 or more nodes in it? So let's look at the outer part of this loop here real quick here. So what's happening here? In the no node case, that should be easy for us to verify that we've got it right. What are we doing when we're cloning? Well, we say create a temporary variable called pointer, and we set it equal to the stack top of the source of our copy, right? That's the head node. Now, if that is null, there's nothing to copy. So we ask, while pointer is not equal to null, in this case it would be if there are no nodes in this source. So the while loop has nothing to do. It comes down here and it simply ends and we're done. So in the case where we're copying an empty my stack object, this clone effectively does nothing whatsoever, right? And in order for that to work correctly, we need to make sure that the target of the copy is not left in a weird state. So when we call clear on our self, the target of the copy as part of this assignment, this will leave the object with a size of 0 and the stack top pointer set to null. by definition. And we will copy the size, which will be 0 anyway, so this will zero that out as well. This accomplishes nothing at all, and the assignment is then complete. Let's look at the copy constructor. What does it do? Well, it initializes the top to null, and it initializes the stack to the size that it is copying from. Again, we're dealing with the case where the source of the copy is empty. So this will be 0 in that particular case. Clone will not do anything, and we're good again because there's only 2 member variables we have to concern ourselves with. So when the clone is called on a object that's being copied from an my stack with an empty list, it will work fine. What does it do when it gets called with a non-empty list? So before we dive into that one, let's look at a list that is not empty, right? So let's say this is our X, right? What X? X is a reference to a my stack. Remember, it has a stack top, and it has a stack, what was it, size. Okay, so this is going to equal some number, let's say 3. Stack top equals, it's a pointer, all right? So I'm not going to do that. I'm going to just say it's a pointer to a node. Right, so maybe it looks like this, and it has a 1. It might have a 2, a 3, or we set this to 3, so this has to have 3 nodes in it. Otherwise, it's not valid. The one on the end has a null pointer in it. Okay, so this, let's say this is what our X looks like. We want to make a copy of this particular list. So let's go through the code and see what it does. Now, the first thing this loop is going to do is it's going to set up some temporary variables that we use to control our loop with. So let's just set those up. Last equals null pointer. And we have a pointer which equals what? X stack top. So this guy is going to point to here. All right? Before the while loop starts running. So the while loop starts going, and it says while pointer is not equal to null pointer, which is true because pointer clearly now points to an actual node. What are we going to do? We're going to allocate a new node, and we're going to set its value to the value that this PTR variable is pointing at. So how do we do that? Well, we simply say node star new node equals new node PTR right arrow value. Now I'm not going to put the second argument to the constructor in here in this particular case because I don't know what the next node pointer should be for this current new node. Remember, I've replicated the first node in this list in the target. This is in the target of the copy here. And I don't yet have the second node copied in the destination, the target of the copy that's being taken place. So my new node will simply be a new node that is a 1 in it. And because I didn't specify, the default constructor puts the next pointer to null. So it'll create a node that looks like this. And new node will be pointing at it. So what happens then? We ask, look, is last equal to null pointer? And the answer is yes, because we initialized it to null pointer up here, right? Pardon my penmanship there, right? So this is supposed to be an L. Okay. Now, in that particular case, we say then, and only then do we say this stack top equals the new node. Well, that makes sense because stack top at this point will be the first node in the list. So I'm going to just put a big arrow right there. So stack top now will equal that new node that we just made. Okay, we then fall down to the bottom of the loop. We say last equals new node and pointer equals pointer next. So last equals the new node. All right, so now last is going to be pointing down here at the new node. Pointer moves to pointer next, which moves this guy over to here. I probably should have drawn these in the other order. Sorry about that. Okay, so this is the state of play right now. Now what happens? We allocate another new node. So we're going to say new node pointer, right arrow value. This time, that new node is going to have a 2 in it because we've moved pointer over, right? So there's going to be a 2 over here somewhere. All right. And we then come to the if again. We say is last equal to null pointer, and it will never be that again because last at this point will iterate across the nodes as they go. So it will go to the else and say last next equals new node. So last remembers where the last one is I just created, right? And it then says next equals new node. Well, that makes sense because the new node over here at 2, and we wanted to make the whatever the prior one is point over to the new one. Perfect. We then fall out of the bottom of the loop. We say last equals new node. Well, that means that we're going to move the last pointer over to here now. Zoink, right? And we are going to say pointer equals pointer next. So it no longer points to the 2. It will move over to the 3. Okay. And we go then around the loop again. What are we going to do? We're going to say allocate a new node and set its value to whatever the pointer value is. So we now create a 3 over here. This is constructed as a null. 2 still has a null in it. I should have drawn that one as well. I'm sorry. When that was created, it has a null by default, just like the 1 did before it. Okay. We're going to ask, does last equal null pointer right now? And of course it does not. So therefore we say last next equals the new node. All right, well that's this guy here that was null from the constructor. We now point it to the new node. Done. We fall out the bottom of the loop. We say last equals new node. Last now moves over to here. Pointer equals pointer next. Well, what is pointer next? Pointer next is right here, and it's null. At this point, pointer becomes null pointer. All right. We fall around to the top of the loop. It says pointer not equal to null pointer. Up. Now it's false. So the loop stops running at this point. And look what we have. This is perfectly reasonable. We got stack top pointing to a first of 3 nodes in a linked list. These last and pointer are temporary variables, as is new node, all of which will go out of scope when this clone function exits and clean up our mess. So the new stack object, the new my stack, will have been deep copied from the X object that was passed into clone. And with that, you have your new myStack function. I encourage you to test it on its own, write your own little main function, make sure it works properly and make sure that it gets cleaned up, and test your copies and your assignment operations and stuff like that before you dive into the evaluate function. There's nothing worse than trying to debug a stack from an application program that uses the stack.